Hey, and welcome to another video. This time we are going to be coding a skip list. A little while back, I explained how to insert, delete, and search in a skip list. So we're going to get right into it. All right, with say one thing first is that we are going to be coding it where you have references. We have four references per node. So we're going to have the above, below, next, and previous reference. Okay, so it's going to be a little bit more code because of that, but it's going to help you learn. And the reason I'm doing it is so that I can print some statements out at the end, just so you can uh, see that it's working properly. Okay. Realistically, a more efficient way to code this would where you would only need references to the next and below. Because if you remember, whenever you're traversing a skip list, you're going across and down until you find the key, and then you perform whatever action it is. Okay. All right. So let's get started. So the first thing we're going to need is a node class. Okay. So let's create that. Now, generally, I would not use public fields, but it's going to make it less verbose, so you can just focus on the logic and how this is working. Okay. Normally, I make these private and create getters and setters, but so it's a little easier to see what's happening. Okay. So we're going to create public fields, create four of them, because every node has to have a reference above, below, next, and previous. All right, so we're going to have above reference, below reference, next, and previous. And then we need the key that node is going to be holding. So let's create the constructor, and every time we create a node, we're just going to be giving it its key value. Okay. So we're going to say we are going to be saying this dot key equals key, this dot above equals null, this dot below equals null, this dot next equals next, or whoops, null, and this dot prev equals null. Okay, so this is going to start out creating the node. Now you could create another constructor where you pass in all the nodes that you want it to be referenced to. I'm just not doing it in this case. All right. So we have our constructor, we have our node class taken care of. So the next thing is to create the actual skip list class. Okay. So let's do that. Create a new class, skip list. Now, okay, so there's going to be a few things we're going to need here. The first one is we're going to need a head to tail reference. Remember, the head is negative infinity, the tail is positive infinity. You can never go below or above. All right. Those are also, they could be considered sentinel nodes, which I've covered in a W-link video I created. So we're going to say private node head, private node tail. Put those in the same line. Just trying to show what it does. So we're going to have private. We're going to two final fields. These are going to be the negative infinity and positive infinity. So we're going to say private final int negative infinity. So final fields again are capitalized. So to get the minimum value, just like that, we're going to do the same for positive infinity. Oops, integer.max. All right, the next thing we're going to do is we're going to keep reference to the height, like the highest level, so that whenever we are inserting, we can know if we reach the max level and we need to add a new level. Okay, I'll try to explain it again when we get to that point. Okay, so height of skip list equals 0, and then we need to create the random class because that's what we're going to use to be the coin flip whenever we are inserting. So if it's true, that's considered heads. If it's false, it's going to be considered tails. So if we keep it true, we're going to increase the height of that tower. Um, and then if it's false, we're going to stop. Okay. So next thing is to create the constructor for this. So we're going to be starting with a fresh skip list. Okay. So it really, all it means is we have one level. It's the 0th level. We have a head and a tail, and they have to reference each other. So that's basically what we'll be doing first. So head is equal to new node, and that's negative infinity. Okay, and then tail equals new node positive infinity. Okay, I'm also kind of explaining this as if you've already read or listened to the videos explaining skip search. It's going to help you a lot understanding what's going on here if you understand how it actually works. Okay. So then we have to say head dot next equals tail. Tail dot prev equals head. All right, and now that is the constructor. This is instantiating a brand new skip list. All right, brand new. So the first function that we're going to be coding is the search function. So that's used like nothing happens without the search function in a skip list. So we're going to say public, and we're going to return the node that we found. Okay, so node skip search. We have to be given a key so we know what we're finding, right? So we're going to say node n equals head, because we always need to start at the head node, and that's like where we start for every search. Start at the top left, which should always be considered the head, and you go across below until we find the node that we're looking for. Okay, or the node that has the key, the greatest value key, just before what the key we're searching for. So if we're searching for 45 and that doesn't exist, but we found a node with key 44, that's what we would return. Okay. All right. So we set a node variable to head. So while that node, the head node dot below, does not equal null, because if it does equal null, then that means we are at the bottom level and we can't go down any further, because all the below references at the bottom level are null. So while it doesn't equal, while it's below is not null, we're going to say n equals n dot below. Okay, and then we're going to, once we go down a level, then if we can, once we go down a level, then we need to go across as far as we can. So we're going to say while key is greater than or equal to n dot next dot key. So we need its next reference's key value. So we're going to compare it. If the key we're searching for is greater than that, we're going to keep going. We're going to keep going across the skip list. We're going to say n equals n dot next. Okay. Then after we're going across, it's going to go back to the outer while loop. And if we can go down below, if we can go down another level, we do. Then we go across as much as we can till eventually we can't go across, and we can't go down, and we can't go across anymore. All right, then all we're doing is returning n. Right, that's skip search. That's pretty straightforward. We're gonna go down a level if we can, and then keep going across until we can't. Go back to the outer loop, come down again, go across, come down. Like, we're gonna keep doing that until we can't go below anymore, and the key is not greater than or equal to the next reference's key. Okay. So we got that out of the way. So the next thing we need to do is insert a node. This is a little bit in depth because, like I said, there's a good bit to do here. The hardest part about this and coding it is making sure you get all the references correct. All right, it may not necessarily be the easiest thing. So, okay, and again, we're going to be returning a node with this. So public node skip insert. we're going to be inserting it. Oops, int key. We're inserting a key. So the first thing we're going to do is perform the skip search, right? So we're going to say node current let's say position equals skip search, whatever the key is. Okay, then we're going to have an arbitrary node called q. Okay, I'll explain what this does soon. So we're going to start out with the current level we're on. We're going to say -1. I'll explain why in a second. We're going to say int the number of heads is -1. This is really going to, this variable is really just for when you print it, so you can see how many times it actually flipped heads. And then what we need to do first is when we do a skip insert, if the key already exists, then you can't reinsert it, right? So we're just gonna have to return the node that was found, which would be the node with the key that we're already looking for. So say if the current position, so the key, after we did the skip search, the node that was returned, if its key is equal to the key we're trying to insert, then we just return position, and that's the end of that. Okay. Most cases that won't be the case most of the time. So if not, then what we do is we have a do while loop. So we're going to do something while random. This is kind of an easy way to, if you're just doing like a heads or tails like kind of randomness, you can say random.next boolean equals true. So we're going to do something while random.next boolean means it's either going to be true or false. It's going to 50-50 is equal to true. If it's true, go back up to the do loop, do part of the loop. Okay. And remember, if we in the do code block, you always do it at least once. So we're going to say number of heads, increase number of heads, increase the level. So now they are all set to 0. Okay, that's just kind of why I did that, so we can set it to 0 when we're actually doing some of the logic for the skip insert. Okay, so we're going to say, now we're going to have we're going to create a method called canIncreaseLevel. So we're going to give it the current level, which initially to be 0. So can we increase the level? And let's go down here. Let's create a private void can increase level, level. So if the level, so if the current, so basically 0, right, is where we start out with. So if 0 is greater than or equal to 0, then we have to increase the height of the skip list by 1. Okay. So if level is greater than or equal to height of skip list, height of skip list, increase it by 1, and then so after we do the field, the class variable, we're gonna increase that by 1, okay, as well. So then that means we're gonna add an empty level, which is another function. I know it's gonna start like a kind of a rabbit hole, but we're almost out of it. So void private. So now let's create that one where we need to add another level, if we can. Okay. So if the level, which initially starts out at 0 when we go to the skip insert, if that's greater than or equal to the height of skip list, which initially on an empty skip list, 0 is greater than or equal to 0, then we're going to increase the height of the skip list. Okay. We also need this if, the reason we need this is because if it ends up returning heads, then we need to keep increasing the tower. And if we keep increasing the tower and the height of the skip list it doesn't match it, then there's an issue, right? There's a logic issue. So we always increase the level if the current level is greater than or equal to the actual height of the skip list. All right, and remember the level initially starts out at 0 once we enter the do part of the loop, okay? So private void add empty level. So we're going to say node new head node equals new node negative infinity. So what we're doing is we're creating two nodes that will end up being the new head and new tail node. Because like I said, the head node has to always be the top left node in the skip list. And likewise, the tail node always should be the top right node in the skip list. Okay, so we're going to say new head node dot next equals new tail node. So initially, this new level we're creating isn't going to have any other references except for the head and the tail referencing themselves. So then we say new tail node dot prev equals new head node. Yeah. Sorry, I forgot something. So because we're adding a level, that means that there was always one before it. So not only at the head, which is the top left, it has, there's nothing previous to it, and there shouldn't really anything be above the head node. Okay. So whenever we create the new one, we have to make sure that its below reference is the current head. Then we end up, making the new head what we just created. Okay. Hope that makes a little sense. I'll explain it again in a second. Try to. So new head node dot below equals head. So what I'm saying is this new node that we're creating, its next is going to be the new tail node we created. What is below has to be the current head as of right now. Okay. And so we're going to do the same for the tail. We're going to say new tail node dot below equals tail. Now we have to say the current head dot above equals new head node, and tail dot above equals new tail node. It's just the whole thing about skip lists and coding it is just references. You have to keep up with them. Okay, that's it. So now we can say, now that the new head nodes we created, they had the correct references, and now we can say head equals the new head node, and tail equals new tail node. So this new level we created, it's an empty level, and it only has references to each other and the nodes below it, which were the previous head and tail nodes. Okay. All right. So let's go back up here. So we did that. Right. So we're going to at least increase the level one time. Okay. We're going to say Q is equal to position. So that arbitrary node that I created in this method is equal to position. I'm going to say while position dot above equals null. So remember, we're inserting position equals position dot previous. Okay, so we want to insert a node. All right, so if initially there of course won't be any node above a node that a new node you're inserting. There won't be anything above it, of course, right? So we're going to have to shift to the previous node on that level. On the bottom levels where we always start on the bottom level when we insert a node. Okay, insert a new node. Okay, so go back to the previous one. If that has a node above it, then what we do is then that position, the in here will be equal to that. Okay, and so that's going to give us a reference so that we can start, because the whole thing is you need to have the correct references for all the new nodes. Okay, that's this whole thing, and you might not get this right away, but the whole thing about this is setting up the nodes so that you can make sure the new nodes you insert have the correct references. Then we're going to say position equals position dot above. So once we have we kind of backtrack until we have on the on that level. So initially we start on the bottom level. Once we backtrack until that node has an above reference, then we say, okay, position equals a position dot above. All right, so now we have a node up here that has a connection to somewhere else on the upper level, on a level above where we're trying to insert, okay? Because eventually we're going to have to make sure that its next is the new node, okay? That's this whole thing. So now we can say this. So while we did that, when I said Q equals position on line 55, we still have, so now position is some previous amount of nodes on the bottom level, and then it's up one. Well, now Q is equal to that original position, to the original node, okay? So Q, we're going to say insert, we're going to create another, method here. So it's called insert after and above. Insert after above, okay? Position Q key. Okay, so let's create this so you can understand exactly what it's doing. So private node insert after above. And we have some parameters to put in here. So we have node position, node Q, and then int key. Okay, so we're going to say node, where I have this new node that we're creating, equals new node key. So currently we created, this is the new, so remember we're inserting a node. We're inserting this new node with the key. So right now it doesn't have any, it's just somewhere in the ether. It has nothing, no references right now. So node, so this is the node before new node equals position dot below. Okay. So this is saying that the node before the new node and the in position below it. Okay. So we're going to say set before. We're going to have two more methods in here. Set before and after references. Might make sense once I show you this. Okay, this might be a good bit right away. Set above and below references. Position key new node before new node. Okay. Okay, I'll catch you up here because I've already coded some of this out. All right. Of course, we have to return new node. Okay, so let's start out with the set before and after references. So we're trying to insert a new node, but then we got to set the before and after, and then the above and below references. Okay. Private void set above and below references. Nope, let's do before and after. Sorry, in the sequence. So we're going to say node Q and node new node. So what are we doing here? Say new node dot next equals Q dot next. Okay, so this new node that we're inserting. Okay, so Q was the position that we found that was the greatest key the node that had the greatest key before the one we're going to insert. So like I said, if we're trying to insert 45, then this might be a node, say 44, could be 42, whatever. Okay, so it's so the new node's next reference is got to be what that node's next references was. Okay, let's say new node dot previous equals q. Okay, and then we're going to say the original node, or the one that we found. So q dot next dot previous equals new node. So it's the node that we found, say it was 44. We're trying to insert 45. Say its next was 46. We're saying q dot next, so 44 or 46 node, and then its previous is equal to the new node. Okay. Then I'm going to say q dot next equals new node. All right. So we inserted this new node on the bottom level. Well, initially on the bottom level, and we're saying it's before and after references. Okay. Now we need to set the above and below references. I know this is a lot. There's just so many referencing that you have to like worry about. I know it's a little bit ridiculous, but that's why I'm saying coding. Just worrying about the next and below references is much easier. But this is all for learning. Okay. So node position, int key, node new node, and then node before new node. So we're giving above and below is a little harder. Okay, a little bit more to code. So let's have if. So what are we given here? The position, which is the above level, the key, the new node, and the new node that we're inserting, brand new node, and then node before new node. Okay, which is on a level below the new node. Okay, which could be null, right? So we have position being above the level above the new node we're inserting, and node before new node being the one below it. Okay, this is all to help with setting this up. Node. So if the node before new node does not equal null, because it could be, because like I said, if you go down twice, if you go below the bottom level, that's got to be null. So then we wouldn't have to make a reference because it's already set to null when we create the node. While true, if node before new node dot next dot key does not equal key, then node before new node equals node dot next. Else. And we have to break at some point. So if the node, if we're down, so now we're down at a level below the node we're trying to insert. If its next dot key does not equal the current key, then we kind of keep moving over until it does. Because we just keep moving over until it does. It obviously can't happen on the initial key level, but then if you hit heads and you have to add a new level, then you have to do that. Okay. So while true. So new node dot below equals node before dot next, and then node before dot next dot above equals new node. So we've basically found the node we're looking for. That's like the level below the node we're trying to insert. Its next, we found that node, and the one its next key is going to be directly below where we need it to be. Okay. I know this is a lot. I'm sorry. Position does not equal null. Then if position dot next dot key equals key, new node dot above equals position dot next. Okay. So if now we're in the level above what we're trying to insert. So obviously make sure it's not null. We can't keep moving. If position.next.key, which it should be, is equal to the key, then that new node we're trying to insert, its above is position.next. Okay. Whew. All right, so what are we doing now? So I think we finished. So we finished skip insert. Okay. So now we're going to move on to the last one, which is remove. It's definitely simpler. Still a little bit of coding, but it's simpler. Okay. Missing something here. 1 second. Oh, whoops. Of course, we have to return Q. All right. Now we're going to remove. This is the last thing we're going to need to do. This has been a lot to code. I know. I had to do it myself to figure this out. So node remove. We're going to have to give it the key that we want to remove. So node to be removed equals skip search key. So if you want to remove the node, you have to find it first, right? So if node to be removed dot key does not equal the key we're trying to find, or the key that we found, then return null, because you can't remove it if it doesn't exist. So what we have to do, we're going to create a method called remove references to node to be removed. And while node to be removed, so we're first remove all the references to it, okay? So while it does not equal null, remove references to node to be removed. If node to be removed dot above does not equal null, node to be removed equals node dot above, else break. Return node to be removed. So let's create this real quick. Private void remove references to node to be removed. At any point you just need to kind of stop for a second and just code this out. That's fine. This is going to be a long video. After node to be removed equals node to be removed dot next. So what I'm doing here is I'm just kind of setting this up here. Node before node to be removed equals node removed dot previous. So now we have the previous and next references to the node we're trying to remove. Okay. So then we can say before, no, that previous node dot next equals after, and then after, whoops. After node to be removed dot previous equals before node to be removed. Okay. So we're finished coding it. I'm gonna go ahead and code out the a print print method. I can't talk. So I'm just gonna go ahead and do that. Pause the video whenever you see it on the screen, so that you can code it yourself. It's just so I can just kind of decrease the time on this video, and then we're gonna test it real quick, and we'll be done. Okay, we're back. So here's what we're gonna do. Skip list here. Oh, let's come down here. So go ahead and pause the video, code this out, and then I'm going to start. All right, then I'm going to start with the testing. Okay, so you've copied that, or you don't have to. I'm just here to show you how it works. Okay. So what we're going to do is say skip list. Skip list equals new skip list. And we're going to say skip list dot insert 5 or 6, whatever. So this dot skip insert. Let's do 15. Skip list dot skip insert. Let's say 4. Okay. Then we're gonna say skip list dot print skip list, and then let's try removing. Try removing 4, and then skip list dot print skip list. All right. Hopefully this works. Let's try it. Oh wow, we had to print a lot. Okay. So we hit heads a good bit apparently. So we see we insert 6, 15, and 4, not in the same order. And here we are at 0 level. We have the negative most integer value and the positive most integer value. And it's in this order. So it looks like 6. It looks like 6 was the one that hit heads a lot. Okay, so then we removed 4. And as you can see here, we're at level 0. And 4 is not there. All right, let's hit play again. It's odd that it was that many. Okay, so it looks like each of these, 4, 6, and 15, both all hit heads once and then hit 6 again. Let's play again. So you see here, we moved 4. Let's try to move a number that doesn't exist. Okay, that number does not exist. And both of these should be the same. And looks like they are. Okay. Let's do this. Just be a blank skip list. Level 0, all it has is the minimum value and the maximum value. Now I've already tested this. Whenever you debug it, you can go directly into the references and see what next, below, previous, and above are, and it will work. Okay, I've had to debug this myself a good bit to make sure my code worked correctly. So we're done. This is how you code a skip list. If you have any questions, leave them in the comments below. I know this was a lot. It's a long video. So thank you guys so much. I'll see you guys next time.